My name is Jiashun too. Please just call me Jason. I'm from ZT Corporation. At the very beginning, I want to say, actually, after experiencing a very hard time this spring, and ZT is already recovering from this event and back to the industry. And now we are running even more faster to providing innovation end-to-end 5G solution to the customer and the market. Okay, let's come back to the technical issue. Okay, my topic is talking about the evolution to the common core for the 2.3.4 5G. Okay. So I think everybody is here about a lot of information about 5G all these days. So 5G is such a big cake ahead, so everybody is running rush to share a piece of it. But I have to say, we still have a contract and the requirements to 2 or 3G. Even it is slowing down, but it will be last for years. And also for the 4G, we understand the 4G subscriber is still growing for almost the next 2 or 3 years. And the connection all over is reached to 3 billion, okay? And of course for the IoT. So nowadays we have a narrowband IoT, and I think we have investment a lot of from the vertical industry, no matter the application, also the terminal. So those kind of terminal and then vertical application is supposed to be running at least 3 or 5 years. So, and the last session is that fixed mobile convergence. We understand fixed access is talking about the release 16 in the 3GPP, and also fixed access is also an important part of our network. So what I mean is, the 5G is perfect. It's a big requirements, but we have to understand the 2, 3, 4G will be existing for a long time, okay? It's a real time, it's real. So for the operator, it will be exhausting for us to keep all those 2, 3, 4, 5G parallelly for a long time. It exhausts. So we have to find a way to make this happen, but with an efficient way. Okay, so that is ZT propose. So we propose to make a convergency at core network site, which using the 5GC architecture to match the 2, 3, 4G core network function. So you can see, this is a standard 3GPP service-based architecture for 5G comms. But we can expansion some typical network function, for example, the AMF, to support MME and SDN function. And also for the SMM, to expansion this function to gateway control function. And in the same time, for the UDM, we can expansion to support HSS and HR function. So what's the benefit? So if we do this, so we can using the 5G architecture to achieve a standard 2, 3, 4G core network function. And at the same time, brings all those 5G core benefits. For example, it should be cloud native based. It can support stateless even for the EPC function. And also it's CAPS, control and user plan separation, and of 3-level decoupling, and we have a unified cloud OS, and also we can support hardware accelerate for the 4G application. And of course, the target is all-in-one cloud network. So this way is kind of a way to achieve a converged core to anchor all those latency, access, new access, and also fixed access in one point. Okay. This is our concept. So the picture shows our hierarchical service-based architecture for the platform. So this is a standard one. So we have a common service, platform management, interface routing, load balancing, signaling, and a network function, as I just mentioned. Of course, the network function will fulfill the 3GPP, AMF, UDM, SM function, but we want expansion, those kind of function to support 3 or 4G function as well. So for our, the SPA architecture is already standardized, and ZT now is ready for SPI, IoT, and commercialize. Okay. Well, let's come to what's the benefit if we make the convergency element, network function, in this 5G architecture. The first scenario talking about the control plane. So if the MME and AMF is convergency in one network function, and the gateway control and SM is converging in network function, so in this scenario, if the user equipment hand over from the 5G coverage to the 4G coverage, so the unified control can provide seamless mobility and interworking. Okay, this is one scenario. The second scenario, you're talking about the user plane. Because no matter it's a 4G or 3G or 5G, user plane could be converged as well. So as I just mentioned, so for the user plane, it could be control plane and user plane decoupled. We can introduce this concept to the 4G network, and of course get some benefit. And also for the if we do have support hardware acceleration solution for the user plane, so all this benefit could also introduce to the virtualized 4G network as well. So the last scenario talking about the user profile, a centralized, maybe converged user profile data center, UDM, and converge with HSS and HRR. So we can get some unified data layer for evolution to 5G smoothly. This is another new scenario. And of course, because we are in this UDM, we have a cloud database. So that is mean, so even for the 4G scenario, we can get some stateless features in the, target 4G network. This picture talking about how we can use this common core to help us to migration to the target 5G. So this talking about standalone. In some aggressive service provider like China Mobile, they have selected standalone mode for their target 5G network, and they have very aggressive project. So in this case, at very beginning, so in the trial phase, you can introduce a new common core acting as a 5GC for an independent 5G network, which will not affect existing EPC network. This is for trial, and I think it's already happened in China. And the second phase, the pre-commercial or early commercial stage, so the common core can working with the existing EPC network to providing with interworking the very early stage. And in the final stage, because we can update this virtualized EPC using the common core. So that because a common core can working as a virtualized EPC as well, because we support, as I mentioned, MME and HSS and also the gateway as well. So in this case, they will help the operator to introduce 5G smoothly and migration to a target 5G network. Talking about the standalone, but actually we also support a non-standalone solution. So this is some scenario talking about a non-standalone. For example, nowadays we have a physical EPC, and we do some have a virtualized EPC for the expansion. If you're choosing the non-standalone road, so you can upgrade the using our common core to upgrade the virtualized EPC to EPC Plus. And somebody said this is a 5G EPC to support non-standard NAND. I have to say, our common core is a pure standard NFV. It could be running on most common cloud platform for the industry. It's kind of application. So that is mean it could be running on any, 5G target cloud platform as well. So it could be upgrade any virtualized EPC as well. So this is one option for non-standard NAND. Another one is you can just, if this one cannot upgrade, you can just upgrade the virtualized EPC to EPC Plus as using the common core. Okay, this is another scenario. So, of course, let's talking about standard NAND. So in this case, you can using, if you're standard NAND, you can using the common core, working as standard 5GC to introduce, 5G. And in the future, another way is a virtualized EPC can also upgrade to 5GC as well. So I think the common core can provide our customer a lot possibility for a lot of choice, no matter it's standard NAND and a non-standard NAND, so we can make all the choice as well. So actually, in fact, the common core can work as, virtualized EPC, EPC Plus, maybe 5G EPC, standard 5GC, and any combination of them. This give our customer many choice, flexible, to start with their existing network, to target 5G network as well. I think this is 3GPP roadmap and also ZT roadmap for EPC. Actually, in fact, ZT has already deployed almost more than 100 virtualized EPC all over the world. From, I think, maybe 4 years ago, we have, virtualized EPC in Vietnam. We have virtualized EPC in a lot of countries commercially for years. And, of course, we do provide our standard 5GC for standard NAND for any trial, and for example, KPN, China Mobile, China Telecom. And one of the big changes is that at the end of this year, we are going to actually stop the legacy virtualized EPC, because this one is, as I mentioned, the common core is going to support the virtualized EPC features and the combination of the 5GC and the virtualized EPC as well. So in this case, in the maybe, next year, so the common core will handle all the scenario, no matter it's virtualized EPC or standard non-standard EPC Plus or standalone 5G core. It could be handled all the scenario. So we don't need two product line. In this case, we just need one product line for all scenario. And we believe because it could be working as a combination of all scenario or some of them, so it will handle all this one. For the existing customer, which is using virtualized EPC, of course, it can support using our common core to upgrade their virtualized EPC to whatever you want. For example, you can upgrade it to virtualized EPC Plus to support non-standard NAND, or to 5GC to support standard NAND. And also, if you just do not think about 5G, you just want to expansion your 4G network, so you can also using this common core as a standard virtualized EPC, which sometimes it can working as a pooling with a legacy physical EPC as well. So to my understanding, no matter nowadays you are trying to introduce 5G or you want to expansion your 4G network, common core is also the best choice for you. Well, let's come to the common core takeaway. So what is common core? It's one of the standard 5G core architecture, but it's implementing 2, 3, 4G, even fixed core features using 5GC architect. Second, It can work as a standard EPC to introduce 5GC benefits to 4G network. So you can, okay, even you don't want to 5G now, you can get this common core as a virtualized EPC to get some benefit. And it can work as EPC plus, and or maybe somebody saw the 5G EPC and the 5GC to support, no matter it's a standalone and a non-standalone. It's a good choice to introduce 5G. And the target network working mode is 5GC and plus EPC. So to achieve the ultimate convergence of the core network, it's the, I think maybe this is the ultimate convergence of the 5G. Okay, so this is the best way. I mean, the common core give you a lot of solution. We have to be any core network you like to save investment on the 5G expansion and also evolution to network to 5G very smoothly. It's a very good choice for our customer to enter market. Okay, any question? Yes, please.
I think we're recording if we could pass the mic.
Yes, please. Gentleman with glasses. Okay.
Hi. Is your common core 3GPP compliant?
Yes,
from
of
the
course.
Interfaces point of view?
Of course, we are complying all the 3GPP requirements, no matter it's 5G or 4G. So, I mean, it can working as standard EPC, follow the 3GPP to interworking with the legacy 4G network. And of course, it can working as a standard 5GC to the NR or, okay, whatever. Yes. I think actually you can regard it, the common core is the way to achieve one of the standards. But the things I have to say is kind of equipment to achieve 235G 3GPP standardized, okay, in one equipment. Of course, you can see it's actually a one software, it's a virtualized. It could be running on most of the common cloud platform. Yes.